Hey guys, it's Miss Delcambre. So today we're going to be going over multiplying and dividing inequalities with negatives or with rational numbers, mostly dealing with negatives. Okay, so you'll need your 13.4 notes, and they'll look like this. All right, and let's get going. All right, so let's look at these inequalities here. So we have 3 is less than 4. Well, that's a true statement. Okay, 3 is always going to be smaller than 4. So now let's multiply each side by 2. So then 2 times 3 gives me 6. 2 times 4 gives me 8. My inequality symbol will stay the same. Okay, the new inequality, is it true or false? Well, this would be true because 6 is less than 8. 6 is less than 8. Okay, let's look at this next one. So we have 2 is greater than or equal to negative 3. Well, that's a true statement. So now I'm going to multiply each side by a 3. So that 2 becomes a 6, and that 3 becomes a negative 9. My symbol, I'm going to just move right over here. And is 6 greater than or equal to negative 9? Well, it is greater, so this is also a true statement. Okay, let's look at this one. 5 is greater than 2. That's a true statement. Now I'm going to multiply each side by negative 1. So 5 times negative 1 gives me negative 5. And 2 times negative 1 gives me negative 2. I'm just going to move this sign on over. So is negative 5 greater than negative 2? Well, no, it's not. This would be a false statement, because negative 5 is further away from 0 on a number line than negative 2. Okay, let's look at this next one. So maybe that was just with positives. Let's check out these negatives. So negative 8 is greater than negative 10. Well, that's a true statement. Well, let's multiply each side by negative 8. So negative 8 times negative 8 gives me a positive 64. Is that greater than negative 8 times negative 10 gives me 80? Well, no, not where we know. 80 is always bigger than 64. So this is a false statement. So do you see how multiplying with inequalities with a negative, my inequality doesn't remain true, it becomes false. So maybe that's just with multiplication. Let's check it out with division. Let's see if there's like a fluke here. All right, so let's do division. So 4 is smaller than 8. 4 is less than 8. That's a true statement. We're going to divide each side by 4. So 4 divided by 4 gives me 1. 8 divided by 4 gives me 2. I'm going to move over my sign. Yes, 1 is less than 2, so this is a true statement. Okay. Here we have 12 is greater than or equal to negative 15. That's a true statement. So I'm going to divide each side by 3. Well, 12 divided by 3 gives me 4. And negative 15 divided by 3 gives me a negative 5. I'm going to move my sign over. Well, 4 is greater than or equal to negative 5. This is also a true statement. Okay, let's see about dividing by this negative. So negative 16 is less than 12. Well, that's a true statement. Well, negative 16 divided by a negative 4 gives me a positive 4. And 12 divided by a negative 4 gives me a negative 3. I move my sign on over. Well, no, that doesn't make it true, because 4 is never going to be smaller than a negative 3. So this is false. Do you see a pattern arising? Well, let's see with these positives. So 15 is always greater than 5. So let's divide them both by negative 5. So 15 divided by negative 5 gives me a negative 3. And 5 divided by negative 5 gives me a negative 1. And bring that sign on over. Is negative 3 greater than negative 1? No. Negative 1 is closer to 0 on that number line, so making it bigger than negative 3. So how can I make these true? How can I make these true? Well, there's where that trick lies. So remember yesterday when I said I need you to circle that you multiply or divide by the same positive number? Remember I said positive, make sure you bubble a little circle, make it known that no matter what you do and you divide by the positive, it will remain true. Well, when we divided by a negative, it remained false. But you can make them true. And how you make them true is you flip the symbol. Flip the symbol. You gotta flip it around. So, key thing is when you're multiplying and dividing by a negative, or dividing with a negative inequality, you gotta flip. You gotta flip it around. So if I did that, let me grab a sticky note. Let me look what that was. So if I did this and I flipped my symbol around to this way, and my numbers stay the same, so -5 is less than -2, that makes it a true statement. When I flip this around, 64 is less than 80. That's a true statement. And you just go down here. So when I flip this around, 4 is greater than or equal to -3. That's a true statement. When I flip this around, -3 is less than -1. That is also a true statement. So that shows you that when you are multiplying or dividing by negative, you have to flip the sign in order to make it true. In order to make it true. So here's your rule. If you multiply or divide both sides with the same negative number, so when you multiply or divide both sides by the same negative number, the key thing is negative, you must reverse the sign, reverse the symbol for it to be true. So you've got to flip it. So reverse, so you got to flip it. Flip it around. All right, let's look here at our examples. So we have -10y is less than 60. So I'm going to just go ahead. I know it's multiplication, so I solve by dividing. And I've got to divide each side by this -10. Okay? Because you can't just divide by 10 because that leaves that negative there. You got to take the whole kit and caboodle, the whole -10 with it. So I'm going to divide this side by -10. So then I'm left with y. Flip it around. Just go the opposite direction. And -10 can go into 60 how many times? -6 times. Or you can say, well, 60 divided by 10 is 6, and I have a negative, so it would be a -6. So now we got to graph it. So again, my variable came first, which is perfect. So I'm going to find where -6 is on the number line. There it is. I'm going to put a circle. I'm not coloring it in because there's no line underneath it. And now, remember, this flipped. So now I've got to go in a different direction. So now I have to go to everything greater than -6. So I'm going to go to the right. And again, my inequality symbol and my arrowhead go in the same direction. And remember, when I flipped it, it goes in the correct direction then. All right, let's look at this one. And I'm going to go ahead and rewrite this just because of the simple fact I like my letters, my variables on the left and my numbers on the right. So I'm going to go ahead and rewrite this. So, all right, -t divided by 6 is less than or equal to 7. And do you see that didn't change the value of it or anything because the mouth is facing the 7, mouth is facing the 7, the point's facing the t, the point's facing the t. Okay, so I need to multiply this. And you see this negative attached? Go ahead and multiply it by that -6. So that negative goes away along with that 6. Multiply this by a -6. Okay, So that goes away, leaving me with t. I've got to flip this around, so I'm flipping it around. Just got to think of it, sorry, like a spatula underneath to flip your pancake. And 7 times a negative 6 gives me a negative 42. So I'm going to find where negative 42 is on the number line. Oh, I'm going to circle it. I'm going to shade it in. Okay. And I'm looking for all things greater than negative 42. Greater, I'm moving to the right. Moving to the right. Now remember, you're like, well, Miss Delcambre, those are the same. Remember, I rewrote it, so it looks like this. And even if you can double check, okay, even though that this is the same direction, the mouth is now facing the T instead of the 7. Okay? All right, let's look at this question, this word problem right here. Every month, $35 is withdrawn from Tom's savings account to pay for his gym membership. He has enough savings to withdraw no more than $315. How many months can Tony pay for his gym membership? I remember this question because Tony and Tom, two different people, don't know who it is then. All right, so let's look for some key important information. So every month, that means I know I'm going to be multiplying something. $35, it was withdrawn from his account. He has enough money, he has enough to withdraw no more than $315. So how many months can he pay for his gym membership? So he has no more than. So $315 is his maximum amount. So the mouth needs to be open to 315, and it can also equal 315. So it's less than or equal to. So our amount needs to be less than or equal to 315. Now, it's $35 every month. That every means that's multiplying. So here we have 35 times, I'm going to put M for months. So this is how our inequality would work. All right, to solve that, we would divide each side by 35. Divide each side by 35. And my M needs to be less than or equal to 9. So he has a maximum of 9 months for his gym membership. For his gym membership. Okay. And let's turn our page over and we're going to do some practice problems. So negative M divided by 7 is greater than or equal to negative 1. Okay, so that's one. I want to do another one. So negative 12I is less than 60. And x over 5 is greater than 4.5. 4/5. Let's do negative 4/5. Okay? So let's go back up here to this problem. So we're going to solve them, and then we're going to graph them. That's why I have this space over here. All right, so looking here, my variable is M, okay? So it's being divided by 7, but it also has this negative beside it. So I need to get rid of both of them to get the variable by itself. So how I do that is I multiply by negative 7. So if I multiply by negative 7 on that side, I need to multiply by negative 7 on this side, leaving me, so this cancels out, leaving me with M, and then negative 1 times negative 7, it's supposed to be a negative 7, gives me a positive 7. Okay, now I need to flip my sign, so my mouth needs to face the other direction. So it will look like this. Okay, so it would be m is less than or equal to positive 7. And how I would graph that is I start off with a blank number line. I need that number somewhere on it, so I'm going to put 7. I always go one above and one below. So I'm going to graph it. I'm going to put a circle at 7. I'm shading it in. I'm looking for all numbers less than or equal to 7. So less than, I'm moving to the left. So my arrow is going to be to the left. And do you see how I put the arrowhead there, guys? Arrowhead means that it continues on. Don't just draw a line, make sure it's an arrowhead. Okay. All right, let's move to our next one. We have 12i is less than 60. So if I'm looking at this, the I is my variable, so I need to get it by itself. So I need to get rid of this 12 and this negative, so I divide the whole thing by negative 12. If I divide that side by negative 12, I divide this side by negative 12. Then this cancels out, leaving me only with I on the left side. Okay, I flip my sign over, so just think of it like you're scooping grilled cheese and you're flipping it over. So it's going to look like this now, which will be greater than. And 60 divided by negative 12 gives me a negative 5. All right, how I would graph this is I start off with my number line. It's blank. Negative 5 has to go on it. And I'm looking for a number above negative 5, so negative 4. And one number below it is negative 6. Now remember, when you're writing your number line, when it comes to negatives, you have to think backwards. It's backwards. So the larger number is actually the smaller one. So make sure you're paying attention to that. Okay? So when I graph it, my circle is going to be at negative 5. I'm looking for all numbers greater than negative 5. Greater, I move it to the right. So my arrow is going to the right. And it's going to be left open because there's no line underneath there. All right. And my last one that I'm going to do does not have a negative. So we're going to watch this because it has a fraction. That's why I wanted to show you this one. So x divided by 5 is greater than negative 4/5. So I need to get rid of this dividing by 5. So I multiply by 5. And when I multiply by 5 on this side, I multiply by 5 on this side. And it's like 5 over 1. So if you think of it, it's like 5 over 1. Because that 5 over 1 and 5 are the exact same thing. So then I'm left with x. And then negative 4 times 5 gives me a negative 20 over 5 times 1 is 5. My symbol stays the same because I'm multiplying by a positive. So it stays the same. Now, I have an improper fraction here, guys. So I'm just going to rewrite it so it's a mixed number. Or actually, if you look at it, it's not a mixed number because 5 can go into 24 times. And a negative and a positive give me a negative. So my answer would be x is greater than negative 4. So when I graph this, I'm going to have my number line right here. Negative 4s I'm going to put on there. And I always go one above and one below. So negative 3, negative 5. Now find negative 4. I'm going to put a circle on it. I'm not shading it in because there's no line. And I'm looking for all numbers greater than negative 4. So greater, I'm moving to the right. All right. And that does it for our notes for today, guys. The key thing for this that I want you to remember is when you are dividing or multiplying with negatives, you flip the symbol in order for it to be true. That is the one thing that's different than what we learned yesterday. That's the one thing that we learned that's different than what we had yesterday. You have to flip the inequality symbol for it to stay true. All right, so that's the one thing you've got to remember. Well, that's it for today. If you have Miss Peeler, make sure that you are paying attention and going into her Google Classroom. If you have me, same thing. You want to make sure you're looking and going into your Google Classroom. And that does it for me today. Have a wonderful day, and we'll talk to you later. Bye.